Wanted to go through another example with the decreasing mthly annuity. So let's look at this particular problem. We've got a 5-year annuity immediate that pays 25 at the end of each quarter during the first year, 20 at the end of each quarter during the second year, and so on down through the 5th year. The nominal interest rate is 8% compounded quarterly, and let's see if we can find the present value of this annuity. So we notice that this is a decreasing mthly annuity, so kind of the reverse of what we did in class yesterday. In the first year, we notice there's a total of $100. 100 is split equally among 4 quarters. Then that total yearly payment decreases by 20 each year until we get a final 20 total yearly payment in the 5th year. So one of the first things we need to do is find that annual effective interest rate, because again, the total payment is over the annual period. So we're given a nominal interest rate in this case, a nominal quarterly interest rate. So we can plug that in. It was 8% compounded quarterly. So if we put that in and solve for little I, we get 0.08243. So that little I is what's going to go in our decreasing mthly annuity immediate formula. A lot of words. So it's 20 out in front because that is the amount, the total yearly amount that is the last payment and is the amount of decrease per year. So notice it's not the $5 payment that is in the each of the last 4 quarters, it's the total last payment. So in that case, it's 20. We have our interest rate is I, but we use the annual effective interest rate because, again, we're doing the totality of the payments over the year. So we have our formula here. So we have N minus A5 of I for our annual effective interest rate, but our nominal interest rate was what goes in the denominator. So plugging those all into our calculator, we see those different pieces and finally get 258.19 for the present value. So this is using the formula, straightforward application of the formula, but remembering again that we need to use a $20 total yearly payment, also with the amount of decrease, rather than $5. But also, like I mentioned last time, well, right at the end of class last time, is that there's another way we can look at this. We can think of this as a decreasing annuity paying 25 at the end of the first year and then decreasing by 5 for each of the next 5 years. So we have our regular decreasing annuity formula. Notice in this case we have the annual effective interest rate in both places in our formula. And we get a little over $62 using our formula in our calculator. So notice that's just one piece of it. We have 4 different pieces. So notice again, we have those payments that are at time 1/4, time 1/2, and time 3/4. We can all move them forward to time 1 by multiplying them by the appropriate factor. So to get the one at time 3/4 to time 1, we can multiply it by 1.02. To get the time at 1/2, the payment at 1/2 to time 1, we multiply it by 1.02 squared. And then to get the payment that's at time 1/4 to time 1, then we have 1.02 cubed. So even though I wrote respectively here on the slide, it's actually reversed. So we can we moved the payments forward by that factor. We can move the annuities by that same factor. So really, we had that one decreasing annuity, the 6264, that started at time 1. So that was that decreasing annuity immediate. Multiplying the ones at time 3/4, that starts at time 3/4 by 1.02, it moves that whole annuity to time 1, and we would have that same present value. This one would move the one at time 1/2 to time 1. This one would move the one that's at time 1/4 to time 1. This is now a geometric series that we can add up, or we can just plug those in our calculator, because that's pretty quick. It's just 4 numbers. We can put those in our calculator, or you can do a geometric series formula. But again, if you just type it in your calculator, you can do it pretty quickly and then get the 258.19. So again, it just gives you 2 different ways to look at the same problem and calculate it both ways. So it's a matter of which way you want to look at it, which way you think is easier is the way you definitely should do it. There's no reason to do it two different ways for the same problem. But I just wanted to give you a way to look at the same problem in two different ways.